The metabolic pathway for ND plus synthesis intersects with methylation biology in ways that have real, measurable consequences for supplement response, and those consequences are partly determined by your DNA. When your body processes nicotinamide through the ND plus pathway, the NMT enzyme methylates it to N-methylnicotinamide for urinary excretion. This methylation step consumes methyl groups donated by SAME, which is regenerated through the folate and B12 dependent 1-carbon metabolism cycle. The efficiency of this entire system is significantly influenced by genetic variants in NNMT, NMPT, and NAPRT genes. What this means practically is that two people taking the same ND plus precursor at the same dose may have dramatically different experiences based on their genetic methylation capacity and enzyme efficiency. Someone with high NMT activity burns through methyl groups faster, potentially depleting SAME and creating downstream effects on other methylation-dependent processes, including DNA methylation, neurotransmitter synthesis, and glutathione production. Someone with reduced NMPT enzyme function, the enzyme governing the critical salvage pathway, may respond poorly to NAD plus precursors that rely heavily on that pathway, potentially benefiting from different formulations. The concept of pharmacogenomics, the study of how genetics influence drug response, is well established in pharmaceutical medicine. The same principle applies to supplements, though with far less regulatory infrastructure to enforce its application. Genetic variants in the relevant enzymes are identifiable through consumer genetic testing platforms like 23andMe or Ancestry DNA, with third-party interpretation tools like Promethease or SelfDecode providing relevant SNP analysis. This isn't science fiction. It's accessible right now at reasonable cost. The warning here is about probabilistic interpretation. Genetic insights in this domain are tendencies, not certainties. A NAMPT variant associated with reduced salvage pathway efficiency increases the likelihood that NR or NMN might offer advantages over niacin-only protocols, but it doesn't guarantee it. Genetic predispositions still require empirical validation in the individual. The genetic analysis points you toward the most promising hypothesis to test, not toward a definitive answer. Any protocol derived from genetic data still needs N=1 confirmation through objective tracking. The methylation support implication is practical and broadly applicable regardless of genetic status. Anyone supplementing ND plus precursors at significant doses should ensure adequate methyl donor intake. TMG at 500 mg to 2g, combined with optimized B12 and methylfolate, supports the methylation capacity that ND plus metabolism draws upon. Homocysteine testing is a practical biomarker for methylation sufficiency. Elevated homocysteine suggests methylation is being overwhelmed by demand.